Hi, everybody. Today we are going to talk about the structure of matter. So first of all, we need to make sure we have the correct definition of matter. Matter is anything that has mass and takes up space. That could be a solid, it could be a liquid, it could be a gas, it could be any form of matter. Anything that has mass and takes up space. Remember, anytime you see something in your green notes that is on the screen, make sure you are writing it down. So far, I've given you the definition of matter, which is the very first thing on your notes. In order to talk about matter, we certainly have to talk about the structure of matter. All matter is comprised of atoms. Atoms are the small particles that are building blocks of all matter. They are the smallest piece of any element that still represents that element. So for example, you see in the picture what looks like a block of gold. If you were to look at the block of gold under a super intensive microscope, then you would see all of the individual gold atoms that make up the gold brick.
Atoms. All the matter surrounding us, either living or non-living, absolutely everything is made up of atoms.
What are they?
Particles. They were called atoms because for a long time it was thought that they were the smallest existing entity and couldn't be further divided. However, in the 20th century, it's been discovered that atoms are formed by even smaller particles.
What particles make up an atom?
Atoms are formed by a nucleus and some particles that are permanently around it, which are called electrons. Inside the nucleus, each atom has a number of other particles called protons and neutrons.
Why are these particles bound together and never separate?
Well, they've got a lot of enclosed energy. Are all atoms the same? No. There are atoms which more or less electrons, protons, and neutrons. And they are very different from each other. To classify and study all the atoms known, they've been grouped into a table, known as the periodic table of the elements.
We will be talking about the periodic table of elements soon, but let's just recap all the things we have learned about the parts of the atom so far. We call these particles subatomic particles. There are protons, neutrons, and electrons. Remember, neutrons have no charge and they are found in the atom's nucleus, right next to all the protons. Protons have a positive charge and are also located there in the nucleus. As you saw in that little video clip, it takes an intense amount of energy to keep there's energy that keeps these together, and they're very hard to separate. However, all around the outside are the electrons. Electrons have a negative charge and are located in a field around the nucleus. Remember what we talked about earlier? Remember, we have that neutron, neutral, Nelly neutron. So no expression, those blank eyes, that blank stare. Positive Patty proton with her sparkling eyes, always a positive, perky personality. And then there's an enraged Elliott electron constantly circling outside of the nucleus arcade. So if you can remember those memory tricks to help you keep the particles correct in your mind, those are some really good tricks. Make sure you've labeled the diagram on your notes and filled out this information as well before you move on. Next, we're going to talk about Bohr models. Niels Bohr discovered that electrons not only went outside the nucleus, but there was certain amounts of electrons in certain levels around the nucleus. These Bohr models show where the electrons are placed. He discovered that around the nucleus, the first energy level, or the first round of electrons, there could only be 2 in the first level. In the next level out, there could be up to 8 electrons. In the next level out, there could be up to 18 electrons. So as he made these discoveries, he kept seeing that the electrons, the more there were, the further and further out they were located from the nucleus. Think about how easy it was to transfer charges when we stuck the balloon to the wall. That kind of shows you why it's so easy to pass these electrons back and forth between different atoms. As we're going to learn and study, the atomic number of that atom determines the number of electrons that you have to place on the Bohr model. For example, oxygen. If we looked at oxygen on the periodic table, we would see that it has the number 8 up in the upper right-hand corner. That number, its atomic number, tells us how many electrons there are around oxygen. This means there are 8 electrons surrounding the nucleus in oxygen. Using Bohr's rules, we are going to make a model of an oxygen atom together. Remember, 8 is our magic number, so we need to place 8 electrons. 1, 2 in the first level, 3, 4, 5, 6, 7, 8. Now we have 8 electrons total, 2 in the innermost level and 6 in the next level out, making a grand total of 8 following the rules. Now that we've tried one together, make sure you followed along on your paper. Now you try one with carbon. See if you can place the electrons where they belong. Pay very close attention. What is carbon's atomic number? That's right, it's 6. So how many electrons are you going to need? Yeah, you're going to need 6. So go ahead and place them where they belong. 1, 2 on the innermost level, and that's the most it can hold. Where do you need to put the other ones? There should be 4 left. 1, 2, 3, 4 more. 4 plus 2 equals 6. Awesome work. Now we need to discuss a little bit how atoms come together, because we know atoms just don't sit by themselves all over the place. They're always coming together. This is called bonding, and we're going to talk about a little bit about that later. Atoms combine in different ways to form something called compounds. A compound is a substance that have atoms or 2 or more different kinds of elements that are chemically bonded together. Look at our picture here on the screen. Water, H2O. There are 2 hydrogen atoms and 1 oxygen atom bonded together. We call that a compound because it's made of both oxygen and hydrogen atoms. The number is super duper important. Just because something's made of hydrogen and oxygen doesn't mean it's always water. In fact, hydrogen peroxide is made of 1 more oxygen atom. If we were to drink water, we would be just fine. But if you were to drink hydrogen peroxide, it would make you so sick. Just because a compound has the same kinds of atoms, because there's a different amount of atoms, they're different substances. That is so important to remember. Make sure you draw these models on your paper right now, and pause the video if you need a minute to do so. Another vocabulary word I need to bring up is molecule. Remember, a molecule is 2 or more items held together by bonds and acts as 1 unit. So look at this picture below. You have the same one on your notes. Atoms are single atoms, 1 atom. So you see a bunch of atoms of the same element in part A. In section B, you see molecules. Molecules are 2 of the same kind of atom bonded together in this case. Remember, a compound is when you have more than 1 kind of atom bonded together, like you see in letter C. You can see both the yellow and the blue bonded together, so that's a compound. Then in letter D, you see all the examples together, and we call that a mixture because you have some atoms of 1 element flying around with some molecules of different elements bonded together, and then you see the compounds all at once. Make sure we keep these words straight. To help you do so, I've put together Quizlet for you. Be sure to study the vocabulary and the model in Quizlet. You can head to this website right here to get to your Quizlet, or you can even check Google Classroom. Well, thank you for watching. Make sure your notes are completed. Have a great day.